Okay, so we will begin tonight's discussion. Good evening, I'm Keisha Rogers, and we want to welcome you to the LaRouchePAC October 30th, 2021 discussion with Ben Deniston and Hunter Cobb. These will be our speakers tonight. And before I introduce our speakers and let them go through their presentation, I want to just set the stage a little bit for tonight's discussion by giving you a sense of what we're in the midst of right now. As many of you know, as we are gathering for this discussion, one of the most atrocious meetings is about to take place and is now underway with the current occupant in the White House, President Joe Biden, and several members of his cabinet now over in Rome for the G20 summit that is taking place as we speak now, and starting tomorrow on Halloween, the ghouls of Glasgow in Glasgow are going to be meeting for the COP26 summit that will start for 12 days. Now, I want to point people's attention to a very important article on our website, which I'm going to pull up here now. This was written by Bob Ingram, and I will give a quick note announcement that on Monday, Bob is going to be giving a report on the Glasgow conference and the opening of that. But you should, if you have not read this article already, read his introduction to what's already underway with the G20 summit that started in Rome prior to the COP26 conference. And this really shows you, I want to point out to you the picture that is featured in this article that Bob Ingram put forth, because this is the picture that is the so-called, this is the inspiration for the criminals that will be participating in the Glasgow conference, and particularly those individuals that are pushing a climate policy, the insanity of the zero carbon reduction policy. But as people see this picture, which is demonstrative of the fascist policy that is underway right now as we speak at the G20 summit, to make sure that all nations completely lose their sovereignty by coercing nations to go along with an economic policy of inflation, of physical economic collapse, to go with a banker's dictatorship agenda. This is a picture, and in the article, more is described here, of the fascist Mussolini. And so the conference actually that's taking place right now, all of the participants that are at this conference are actually passing by this image every single day, because this is where they're holding the conference in the center that was made for Mussolini. So this gives you a sense of how absurd and how insane the situation has become right now. Now, let's not forget that as we speak in the United States, what we're in the midst of, and I'm not going to go through this right now, but it should be noted that while Biden and his entourage have left the crisis economically that's confronting the United States, and while we speak, the US Congress is in a complete uproar over this phony Build Back Better so-called infrastructure plan that has nothing to do with infrastructure in the physical economy. What it's focused on right now is a policy to break down real productivity in the United States. It's not addressing the inflation crisis. It's not addressing the border crisis. It's not addressing anything of reality that's confronting the American population. It's not addressing the fact that we have people starving in the United States. But what it does is that this policy is not building back better anything, because we want to spend trillions of dollars on a climate agenda that's meant to kill people. So that's the fact of the matter here. And what we're going to be discussing is we're going to tear apart this so-called climate agenda for what it truly is, and look at, as Ben and Hunter are going to go through tonight, why the climate models have failed, they do not work, and what the truth about climate really is. How do you look at this from a standpoint of a scientific perspective? So let me turn this off here and start to get into our discussion. And for those who are joining us for the first time, once I'm done here, I'm going to invite you to join us in the discussion by pressing *6 if you're on the phone line after the presenters are finished presenting, to ask any questions or make any comments, or press the raise hand feature. And I'll repeat that again for those who would like to join the discussion. But let's jump into this now, because I think these guys have a lot to cover tonight, and look forward to the discussion and any comments that you guys are going to have afterwards. So we're going to start first with Hunter, and I'll let Hunter go ahead and get started.
Okay, thanks, Keisha. Yeah, I've been reading a book by Stephen Koonin, which was published earlier this year, and I would say is probably one of the best books on the market for the educated layman on the whole controversy of climate change. It's called Unsettled: What Climate Science Tells Us, What It Doesn't, and Why It Matters. Now, he's a very competent physicist who was one of the first scientists to do work on computer modeling. He was at Caltech, and he was doing modeling on initially on nuclear processes inside stars, and then he moved on. He was doing modeling for the Defense Department of nuclear explosions and nuclear weapons, simulating nuclear explosions and nuclear weapons. But his work, I mean, he was one of the ones, way back at the very beginning of computer modeling, wrote textbooks on the subject. But he got interested in the whole idea of climate change, because here's a very complex subject. And so he began working on that some, I don't know, maybe 30 years ago. And he was brought into the Obama administration. He was the top scientist in their energy department. But he began realizing this was not an easy subject to develop a model for. And he began realizing there were very big problems. So he wrote this book, Unsettled. The title refers to the fact that, contrary to the line that you hear, that the whole science is settled and that we're facing a great climate crisis, what he says is, no, the science is not settled. There are many matters that are still very murky, and the idea that we're facing imminent doom because of a climate crisis is just not justified. And I don't think he was intending it by the title, but I think Dr. Koonin has unsettled a lot of his peers in the scientific community, as well as people in the establishment, by publishing this book. Anyway, I won't say more about him and his background, but by today's standards, by general standards, he has very solid credentials. So anyway, I want to talk about two things that he covers in his book. One is the computer climate models. The other is really how the message of scientists gets distorted. And this is a very important point. because what he says is that scientists write papers, and there are tons of papers on climate science, as you might realize. And most of them deal with very specific matters. And they generally are very nuanced. Most of them bring up all kinds of new questions to be investigated. What happens is these papers are then read by groups of scientists at the United Nations, the IPCC, this is the Intergovernmental Panel on Climate Change. And then there's a group of the US government called the US Global Change Research Program, which also does these, has groups of scientists who study all these papers of the various scientific studies. And both of these groups then do assessment reports. They study all these papers, and then different groups of these scientists will then do assessment reports, which put out a kind of a consensus of different areas of climate research. Now, what happens in that process is often the nuances and the questions that are brought up by the individual scientists doing a report, often those nuances and questions will tend to be ironed out. And Kuhn in his book points out a number of, he says, in most cases, these assessment reports are actually done competently. But he also says there are definitely cases where there are egregious distortions that come in. And the bias of some of the writers comes in, the writers of the assessment reports. But that's not the end of the story. What happens then is the science writers in the media take these assessment reports, and then they have to write articles, and they have to write articles that then their editors will publish. So often what happens is you'll get a headline that will attract attention, and often that may be kind of wild, but it may not have a whole lot to do with what's actually in the article. The article may be kind of modest, but even the article may be somewhat of a distortion of what was in the assessment report. Anyway, what Kuhn says, this is kind of like a game of telephone. So you have quite a, what the public will read in an article in the newspaper or on TV or whatever is maybe quite a bit distorted from what the scientists originally were putting out. And Kuhn says he knows a lot of scientists who are kind of embarrassed by what ends up being put in the press. But most of the scientists are afraid to speak up about it. And I'll just make a comment that this is Stephen Kuhn's take on this, and I think it's useful, but it does leave something out. As we know from what Ben presented last week, there is definitely a very deliberate agenda being pushed, this Malthusian agenda, and some of the people in the media are definitely pushing this hideous agenda. So Kuhn doesn't address that. Now, on the issue of the climate models, what the scientists are trying to do is take a very complex subject, which has many what you might call nonlinear features, and somehow put them into a list of simultaneous equations, and then have a computer chug away at them and tell you what's going to happen years down the road or a century down the road. Now, there are many problems that can come up in looking at the climate in this way. For one thing, you have what you might call feedback loops in the system. Just one simple example. If you heat up the oceans, they will absorb less carbon dioxide. Now that means there'll be more carbon dioxide in the atmosphere, which will cause more heating, including more heating of the oceans, which will then absorb less carbon dioxide, which will mean more heating of the atmosphere. So you have this kind of feedback. That's just one simple example, which is known by climate scientists. But there are many more things like this. And you just plug a simple thing like that into the computer, and it can lead to equations running to infinity. I mean, kind of like the three-body problem. So one thing they have to do is they have to tune the computer model, so the computer model doesn't just go off the charts. So I'll say more about the tuning business in a minute. But now let's just look a little more closely at these models and how they work. To make a model of the Earth's climate, essentially what you have to do is make a grid of boxes all over the Earth, covering the entire atmosphere and the ocean. And these boxes are stacked on top of each other. I mean, going up to the top, essentially the top of the atmosphere, say 100 kilometers, 60 miles. And each box, let's say, is 100 kilometers by 100 kilometers and 1 kilometer high. It's just 60 miles by 60 miles. And the same sort of thing for the oceans. Now, but in the oceans, actually, because things move around a lot more in smaller areas, they'd be a lot smaller, like 10 kilometers by 10 kilometers in the oceans. Now that means you cover the Earth with something like 1 million grid boxes and 100 million in the oceans. The oceans are deep. I mean, I didn't realize this, but they're on the average 2 miles deep in the oceans. Now, Ben, if you can put up figure 1, that just gives you a kind of rough picture of what you're looking at. But actually, the boxes have to be very thin to make this thing work. It's more like a pancake box. But each one is, say, 100 in the atmosphere, like 100 kilometers by 100 kilometers and 1 kilometer high. So they're very thin. And each one is, you got starting parameters. You assign a temperature, an air pressure, velocity, humidity, plus many other things. And you plug in the generally accepted laws of physics and certain assumptions that the modeler makes about how physical processes work. And then you have a time interval. You're going to plug it into the computer. It's going to say every 10 minutes it moves to the next time interval. And then it's going to be, the computer is going to be set into motion to go through many millions of steps to simulate the climate over decades or a century. So, and to do this, even on the best supercomputer today, can take months. So now just think about a few things. These grid boxes are not small. I mean, 60 miles by 60 miles. That's a lot can happen in an atmosphere grid box that size. You can have a thunderstorm over here. The sunshine can be shining over here. Clouds are a big deal. Clouds are a major variable for climate modelers. They're a lot smaller than 60 miles. And clouds reflect sunlight. They also absorb heat. So modelers have to make what they call subgrid assumptions in the design of their models. And these vary a lot from one model to another. And think about the tropics. Huge amounts of energy are transported vertically in these storms. You have heat being transported from the ocean into the atmosphere and then released in the atmosphere. And this is not very accurately modeled in these boxes. So anyway, maybe I've given you a little bit of an idea of how approximate this whole process is. And what you have to do, I mean, you run one of these things and frankly, they'll be way off. And they've got to, I mentioned this idea of tuning. I mean, you got to run this thing and then tune the whole program and adjust these grid assumptions. And then the idea is, you run this thing on a period of time where you already know what happens, and you see if it somewhat corresponds to what actually has happened, and then you kind of adjust it, tune it to try to make it work better to what actually happened, and then the idea is that if your program seems to correspond to what has happened in the present time, then you can project it into the future. At least that's the theory. So I want to just give a little more picture of what actually is going on in the climate system. Actually, Ben, you can put up the second figure there. If you take the total amount of energy that's coming in to the Earth's, that's hitting the Earth's atmosphere, about 29% is reflected back into space, and 71% gets absorbed either by the molecules of the atmosphere or by the surface of the Earth, including the water, and it gets absorbed and then it gets re-radiated after it's absorbed. And during that period, when it's as it's re-radiated, it comes in mostly as visible light, and then it's re-radiated as mostly infrared, as a lower frequency infrared radiation. Yeah, here you can see that. And about 25% of the total coming in of that energy is used to evaporate water. a very small percentage of it is, I think it's less than 0.1% of the energy coming in. Actually, but a very critical percentage is used by plants for photosynthesis. But the main thing I want to focus on is of the 100% of the energy that comes from the sun, human activity affects substantially less than 1% of this total. Now I want to look at that a little more closely. The energy that's radiated back into space from the surface of the Earth has to go back through the atmosphere. Now that's in the form of this infrared wavelength radiation. With a clear sky in pre-industrial days, with the carbon dioxide was at 280 parts per million. Now, in those pre-industrial days, that 82.1% of the heat radiating from the Earth was absorbed in the atmospheric gases before being re-radiated. Okay, I think you can take that slide down now. But think about that figure. 82.1% of the heat radiating from the Earth was absorbed in the atmospheric gases in the pre-industrial era. That's what you call the greenhouse effect. Now it's a very useful thing. It's like a blanket surrounding the Earth. You know, the carbon dioxide is part of it, the gases that produce that effect. The methane is another one. I mean, there are a number of gases. Water vapor is actually very, very important. And that actually increases the temperature of the Earth by about 33 degrees centigrade, or about almost 60 degrees Fahrenheit. Life would not really function if we didn't have that warming effect. But what I want to get at is, you know, what people are screaming and howling about in terms of man-made carbon dioxide. This in these pre-industrial days, 82.1% of the heat radiating from the Earth was absorbed by the atmospheric gases. Now that figure is 82.7%. So it was 82.1%. Now it's 82.7%. If CO2 levels double from the pre-industrial era up to 560 parts per million, it will then go up to 83.2%. Now that's an increase of 1.1%. Now that's, you know, that's something. You know, human cause is something. But what I'm getting at a certain point, to design a computer model that's going to say something useful about the human impact on the economy, or on human impact on the climate, the model has to be accurate to at least about 1% of the total energy flows of the system. We're saying you have huge amounts of energy flow, and human activity, you know, I mean, what they're saying is that maybe by the end of the century, if we don't do anything about it, you know, human production of carbon dioxide may double the amount of carbon dioxide. And that would create a 1% increase in this greenhouse effect. But what I'm saying is there's a lot of other things that have a 1% or more impact on the energy flows in the in the climate. And we really, our climate models are not that good. And so I'm just saying that we've got to be a little humble about what we're dealing with, because there's just a lot we really don't know. Certainly, and I'll just show a few graphs of some of the UN IPCC studies. Yeah, here's one. It's actually two, but it's hard to see. You can see the black line is actually a couple of black lines, I guess. But that's the well, it's not reality, but it's measurements, or what they call the temperature anomalies, temperature variations from the expected normal temperature. As measured differences from the normal. The magenta, or the reddish line, is the computer model from one of these. I forget which one. There were two of these studies, the CMIP3 and the CMIP5. One was done in 2013 and one was done in 2007. But what I want to point out is two things. One is, if you look at the black line, actually, unfortunately, you can't see the dates. Yeah, you can't see the dates. That's unfortunate. It starts at the very far left. That's about 1900. And on the very far right, it's 2000 or 2000. I think it's 2020. Oh, Tony says the dates are visible. Okay. So anyway, if you look at the period from, if you look at the red line, you see it drops around 1910 or something, somewhere in that period. And then you have this period. The main thing I want to point out is you have this period in the black line, you know, what you might call the actual measurement. You have this period from roughly 1910 to 1940, where you definitely see the temperature going up. And it's going up at a fairly significant rate. Yeah, you can see that. It's not quite as steep as the period in the more recent period from say 1980 to 2015 or so, but it's close. It's definitely a warming trend. But the red line, you don't see that. And this in the model, which is represented by that red line, you really don't, you see a very modest rise from around 1910 to all the way to 1960. It's a very modest increase. So the model really didn't kind of catch that. And this is kind of a consistent problem these models have had. They really didn't quite get, even though they've been doing these for a long time. So that's one problem with these models. Another problem, which you really can't quite see with these graphs, you have these two ones, the CMIP3 which was done in 2007, and the CMIP 5, which was done in 2013. You would think with more data, with more sophisticated measurements and capabilities, that they would have gotten better at doing these computer simulations. But actually, the one done in 2013 had a bigger spread of uncertainty than the one from 2007. Now, why would that be? Well, the only thing I can say is it shows that there's still a lot we don't know about how to model the climate. And I'll just show one more figure. Let's go on to the last one here. Yeah, this one shows, again, if you look at this period from 1910 to 1940, again, you have 3 black lines. They're different data sets, but they all represent reality or actual measurements. And the colored lines are different models. So again, most of the models, you might say, well, they're kind of, but really, they don't quite get that rise. They're much more modest in that whole period between 1910 up through 1950 or so. You might say maybe they're a little bit better. This graph is from the most recent, what they call CMIP 6. This is the one that came out this year. But then you wonder, well, going on from 1950 to 1975, you see there's kind of the actual temperature, they kind of level off in that period. But the models have a real dip in that period. And so why do they really go down in that period? That's kind of puzzling. And then what it does, it creates in the models a much more steep rise from around 1970 or so up to 2000 than what really existed in the actual temperature measurements. So anyway, not a whole lot more to say on that. It just shows that, you know, we still got a lot more to go in terms of making these models. I just want to conclude by making one important point. Maybe this is somewhat obvious, but the climate is not a steady state system, in case anybody was under that illusion. The Earth is part of the solar system, moving through the galaxy. There are many varied processes at work, including biological processes of life, including cognitive processes of humankind. And as the great Vladimir Vernadsky pointed out, human beings in the 20th century have become a substantial geological force. And this should be seen as natural and exhilarating. And I suggest people really think about that. Our discussions of climate should be situated in that context. So that's what I have to say, and to elaborate on one of the aspects of this climate process. I'll now turn things over to Ben.
Thanks, Hunter. Appreciate that overview. I'm just going to add one brief addition to it, and then I think we'll get right into the discussion. But I hope the point's coming across how different the actual science is from what we're told by the propaganda. And when you keep hearing this, I mean, maybe it's just me, but this phrase we hear from politicians and the media about follow the science, follow the science, follow the science, nothing gets me more frustrated and enraged than hearing that, because to me it's a complete abuse and maybe even you could say weaponization of the authority of science. I mean, science is wonderful. It brought us to where we are. It's a key part of human advancement. And to hear these people rely on the authority of science to push their propaganda, should really be enraging everybody. So yeah, to hear how inconsistent and problematic these models are, and how all the propaganda is used to build upon some simple studies some scientist does to spin off these wild scare stories, is really a hoax when you really look at it from that standpoint. I want to just throw in one more relatively recent study into the discussion, just to kind of get more on this issue. What does the real science say for climate change? And this, I think, is remarkable. This is a study that's was done by Professor William Happer, Princeton University, and another Canadian author. I'll get his name in a second when I pull up the slides. But this is being seen by some well-informed people as potentially the complete death blow scientifically of disproving the whole man-made climate change scare. So I want to just give people a quick rundown on this, and then we'll hopefully have some fun discussion on the actual scientific realities of climate change and what we really need to be doing to rebuild this country. Hunter definitely touched on this. Here I have an incredibly well-produced graphic. I hope everybody celebrates my graphic artistic skills here. But just some of the basic science that's being developed now on the greenhouse effect is showing that the impact of CO2 emissions looks to be almost completely saturated. That the more CO2 we add at this point, we're going to be seeing very, very, very little additional warming, to the point that most of the warming that's occurred from CO2 appears to have already happened. And to understand this, you've just got to look at the basic greenhouse effect model. To put it in very simple terms, people aren't familiar with it. Obviously, the sun is a source of energy heating the earth. And that brings the earth up to a certain temperature, and any object has a certain amount of radiation, electromagnetic radiation it releases depending on its temperature. It's idealized. This is called the black body curve for an object. We can get into more of the physics on that in the Q&A if we want. But any object will have a certain amount of spectrum of electromagnetic radiation it releases based on what temperature it's at. So the sun puts the earth up to a certain temperature, heats it up, and then the earth emits a spectrum of radiation. And this is a depiction of, at about the Earth's temperature, what that spectrum of radiation would be. So for the temperature of the Earth, this is mostly in the infrared. This is where the majority of the energy being released by the sun, or by the Earth from being heated by the sun, comes out. The whole greenhouse effect comes in, is that you have an atmosphere that blocks some of that heat energy from the Earth that's being released from the Earth from going back out into space. And so here we have from this paper from March of this year by Professor William Happer, and I'm certainly going to mispronounce this other gentleman's name, but it's Wingarden, something to that effect. The paper is called Relative Potency of Greenhouse Gas Molecules. So here, based on their study, where they did a far more detailed and rigorous assessment of the interaction of greenhouse gases with the heat emissions from the Earth. Here's what it would look like in terms of the spectrum of energy leaving the Earth if there were no CO2 in the atmosphere, if the CO2 concentration was hypothetically 0. And you can see, but all the other greenhouse gases are still included, including water vapor, other things. So you can see the dashed line at the top is the idealized, hypothetical, idealized black body radiation curve of the total amount of energy that would be coming back to space. And you see that there's some of it doesn't, there's these regions where the actual amount of energy coming out doesn't reach that curve. Some of that's because it's not an idealized black body, but much of it is because of the so-called the greenhouse effect, as it's generally called. These other gases are absorbing some of the energy leaving the Earth. So the first point is that there's only so much energy to be absorbed. The second point is that different molecules only absorb certain limited parts of the spectrum, different frequencies. And so we can see that if we go from this current level to the current, or the hypothetical 0 CO2 in the atmosphere to the current level of 400 parts per million, you can see the difference, right? And the difference directly expresses how much heat is now being trapped and contained in the atmosphere. So going from 0 to 400 makes that noticeable reduction in the amount of infrared radiation heat that's actually leaving the Earth's surface, making it up out of the atmosphere and leaving the Earth system completely. These dips, this increased dip, especially in the middle there, is now energy that's now being captured by CO2 in the atmosphere at the current levels, 400 parts per million. And if we want to highlight that distinction in red, here you can see a way of quantifying or expressing exactly how much additional heat is being trapped in the atmosphere because of the current CO2 levels above a hypothetical CO2 level of 0, right? So hopefully that's clear. So this is kind of where we're at now. This is how much the greenhouse effect from CO2 is contributing to warming the planet more as where we're currently at, right? And where we're currently at, despite what you might hear on some propaganda, politicians and news channels, we're not in a crisis. Global deaths from extreme weather events, if you look on now compared to the last 100 years, 200 years, is at an all-time low, right? There's no discernible increase in extreme weather events, despite what you might hear. So where we're currently at now is not some kind of crisis. And where we're going, so if you take the current situation and you double CO2 levels, you take the current level and double it, which is far more than, you know, CO2 is already a certain level naturally before we started adding it to the atmosphere. So to completely double from where we're at now would be a huge endeavor, would be a massive emission of CO2 emissions. And what would be the effect according to this depiction as we're seeing here? There. So I don't know if people could see that, but this deviation here, I'm going back and forth, is how much additional warming would occur as a function of doubling the CO2 from the present levels, which again is a huge amount of CO2 increase. And just to highlight it in red, so again, the red now here is showing going from 400 parts per million to 800 parts per million, doubling the CO2 concentrations in the atmosphere. How much additional energy that would otherwise be leaving the Earth system is being trapped within the Earth system. It's a very little amount, especially compared to the amount that was captured by the first 400 parts per million. So what we're seeing is that over time, as more CO2 has been added to the atmosphere, the amount of energy available to be trapped by CO2 is limited. So there's only so much energy that could even be captured by CO2 itself. And the effective ability of each individual CO2 molecule to warm the planet decreases as more CO2 is added, right? So if we go back to our hypothetical scenario of no carbon dioxide in the atmosphere, the plants would not be very happy about that. The biosphere would not be very happy, right? They love CO2. But just to take this hypothetical case, go back to there being 0 CO2 in the atmosphere. You can estimate what the effective warming power, the more technical term would be forcing power, but how much warming capability each individual molecule could have at 0 CO2 in the atmosphere. It's going to be a lot more because there's a lot more energy that hasn't been trapped yet. You go to 400 parts per million, and that effectiveness, the effectiveness of each individual CO2 molecule now today at trapping heat, at warming the planet is literally 5,000 times less than it was, or than it would be at a hypothetical case of when CO2 is first being added to the atmosphere, starting at CO2 0, right? So compared to that initial scenario, the ability of CO2 to warm the planet is now 5,000 times weaker, which, explains why the change from the current levels to future levels are so low. So I just thought that was an interesting study on the scientific side. I hope people, kind of see the significance of that, because what this is showing us is that the ability of carbon dioxide to have any effect on warming the planet is reaching its near saturation. So the more we keep adding, it's going to have an incredibly minimal effect, a few percent relative to what it had before in terms of the ability to warm the planet, meaning there is no crisis. But they can, as Hunter showed us, they're developing these wild models that they can adjust and tune to come up with any kind of scenario they want. So I'm sure they're going to keep throwing out these scare stories saying, our models are going to show us, we're facing this catastrophe, all this stuff, all these feedback cycles. But underneath all that, if you really get into some of the frontier science questions, it's showing us very clearly, and this is just one interesting study in that direction, that this is not a crisis. We're not facing extinction, as some people are saying. I don't know if people saw that ridiculous ad of a dinosaur speaking at the United Nations, computer-generated dinosaur, warning that we should not go extinct the way the dinosaurs went extinct. I mean, how absurd, like they're actually telling you we're going to become extinct as a species through this process. You could see why people like Kunin are saying some of his fellow scientists are embarrassed when they see how their work is used to try and justify these completely crazy claims. So anyway, I just thought that was an interesting study that, some people are saying could be the complete death blow, to the degree anybody actually wants to follow the science in a real sense and actually look at what scientific arguments are actually being presented that contradict the claims. This could be the actual death blow to the entire man-made global warming scare. So, we kind of threw a lot of people. So Keisha, if you want to add anything else before we open it up, go ahead, or we can just kind of get into questions and see what people are thinking about what's going on with this Ghouls in Glasgow summit.
Well, let's see what people are thinking about. Let me see what I have here.